Alright, Algebra 2, we're talking about 3 by 3 elimination, and this is found in section 3.6. We're going to be doing a lot of eliminating this. There is another way to handle it, but we won't get to that way right away. We're going to be dealing with elimination first. So what I like about this problem is when I look here, I see some very nice stuff going on there. Two of the signs are negative, one's positive. You are going to be choosing, there are three equations here, you have to pair up two at a time and eliminate the same variable. So for instance, I'm going to choose equations 1 and 2 and add them together. And when I do that, kind of ignoring the bottom equation, I get 2x, the y's cancel out, I get 4z, and then I get, on the other side, I get negative 4. Now I'm going to go back to the original three equations, and I'm going to pick another pair. This time, I think it would be easiest to get rid of these two, so I'm going to ignore the first equation and add the second two equations. So, if I add those two, I get 3x, the y's cancel, plus 5z equals, and then I add the negative 3 and the 0. Now I've got two equations with two variables. That's good for me. You know, I like that because now I can look at this and go, okay, now I need to get rid of a different variable, x or z. I think I want to get rid of x, so I'm going to multiply the top equation by 3 and the bottom equation by negative 2. And that's going to give me 6x plus 12z equals negative 12. And that one's going to give me negative 6x minus 10z equals negative 2 times negative 3 is 6. Now I can add these together. When I add them together, I get 2z's because the x's cancel out, equals negative 6. So z equals negative 3. So now I'm asking myself, if I know what z is, how do I find x? Go back to one of these equations that just has an x and a z in it. For instance, this one has an x and a z. 3x plus 5 times negative 3 equals negative 3. That gives me negative 15, so I'm going to add 15 to both sides, giving me 3x equals 12. Divide by 3, divide by 3, x equals 4. How am I going to find the y that goes with that x and z? Take these two, go back to one of these equations in the beginning. I'm going to pick, let's say I'm going to pick the one on the top. X, okay, why am I putting x? I already know what x is. That was silly. 4 minus y plus z, which happens to be negative 3, equals negative 1. So I have a negative y. 4 minus 3 is a 1 equals negative 1. So now I can subtract that to the other side, right? Minus 1 over there, cross that off. Negative y equals negative 2, so y must be 2. Now I have my three pieces of the puzzle. So how do I write my solution to this system of equations? By the way, I'll show you what we're finding, for those of you wondering. I'll write down the ordered pair first. It's actually not an ordered pair, it's an ordered triplet, or ordered triple. So you'll also go in alphabetical order, right? Alphabetical order. So in this case, X, Y, Z. I know, PDQ, but I wasn't going to say it. So 4, 2 for Y. 4 is X, 2 is Y, and Z is negative 3. So that's the solution to the whole question. Now, you're asking yourself, ordered, why in the world do I have coordinate triples instead of just a pair? Well, we're dealing with planes. Not the kind that you fly, but the flat planes that you talked about in geometry. These are two examples of situations where the planes never come together, so there's no solution. Yes, it's possible to have three planes that don't come together in the same point. they could either be like this, or they could be parallel planes. Now there are two other situations. This one is like the corner of a room, so every room in your house that's rectangular has a corner in it, and it has three planes coming together, like the wall, two walls and the ceiling, or two walls and the floor. That is an example of a point where the three planes are coming together. However, we could also talk about three planes coming together into a line. So you could have an infinite number of solutions, and it would be a line that you would be finding. Okay? So those are the different types of situations. Excuse me for yawning. It is Friday afternoon. Well, that's kind of cool. Wow, man, with the colors. Shows up kind of nice. So, I like it. Where did my pen go? Okay. Now, do a couple more of these examples just to make sure you're understanding the whole process. Okay? So, in this case, it's not as easy as the last one, where I could easily. So, I'm actually going to look at this and decide to multiply the top equation by 2, and also the bottom equation by 2. And so that's going to give me 2x plus 2y plus 4z equals 6. The middle equation I'm going to leave alone. And in the bottom equation, negative 2x minus 4y, what am I thinking? Minus 4y, that would be really awful. Plus 2z equals 20. Alright. Now I need to pick a pair to add together. One pair that I see that I'd like to add together is the first and the third. The first and the third. Those two add together and give me, well, the x's cancel. Then I get minus 2y plus 6z equals 26. And I also see the last one and the second one. Those could be added together, right? Because they got 2x and negative 2x. And when I add those together, I end up with a negative 3y and a 5z and a 27. So now we have equations with y and z in them, I should say. So let's see here. How about we multiply this one by 2 and this one by negative 3. So that's going to give me negative 6y plus 10z equals 54. And this one's going to give me 6y minus 18z, and negative 60 and negative 18, that's negative 78. Now I can add these together. The y's would be eliminated. Negative 8z equals, let's see here, negative 24. Divide out the negative 8, z equals 3. Okay, now I need to start the process of working backwards. Pick an equation that just has y's and z's in it. So like negative 2y plus 6 times 3 equals 26. That's 18, so I'm going to subtract 18 from both sides, giving me negative 2y equals 8. So y equals negative 4. Taking these 2 points, I'll go back to one of the other equations. It doesn't matter which equation I choose. Let's pick that one in the middle. Let's take this one up here. Let's see, x plus y is negative 4 plus 2 times 3 equals 3. So I plugged in z and y because those are the ones I know. Negative 4 plus 6, that's a plus 2. And if I subtract that 2 to the other side, negative 4 plus 6 is 2. Good. And then move that to the other side. I get 1 equals x. So 1, negative 4, 3 is the coordinate if you go x, y, and z. Now question 19 is a story problem, which I'll just set up with you. I know that we can go ahead through the process of solving this, but I just want to get it set up. It says a company placed $1 million in 3 different accounts. So if we had money to place in 3 different accounts that would total $1 million, that is an equation, right? The money from one account is called X, the second account is called Y, the third account is called Z. Those are the amounts of money. It says it placed part in a short-term note paying 4.5% per year, okay? I'm reading this from the textbook, right? So it placed part in short-term notes paying 4.5% per year. Twice as much in government bonds paying 5%, and the rest in utility bonds paying 4%. The income after 1 year was $45,000. How much did the company place in each account? Okay. See if we can come up with our second equation and our third equation here. It placed part of the money in short-term notes paying 4.5% per year. So this next equation is about the interest. We'll call this the short-term notes go in this one. The bonds are in the next one. They paid 5%, and the rest went into a utility bond paying 4%. So that gave me a final income for the year of interest of $45,000. Now, if I were you and I were solving this problem, one thing I would do is I'd multiply everything by 1,000. Now, why would I multiply this equation by 1,000? Because I want to move the decimal over 3 places. So I have 45x. That would make 50y. That would be 40z. And then, of course, if you add 3 zeros, that would be 45 million. So that would help you to deal with nice numbers. So I'm looking at the other information. It says it placed part in short-term notes and twice as much in government bonds. So if you think about the short-term notes as X and twice as much in this account, this number is bigger. So Y equals 2X. Now, one of the reasons why this is not a fantastic question is because it involves substitution. It's not a straight elimination question. But it is clear that you could use this, putting it in 2 places, here and in here, which would significantly cut down on your elimination and give you a couple different equations with just x's and z's, and then you could continue from there with elimination to figure out what x and z and y are. We'll finish that one up in class, so give yourself enough room to finish that. Question 29 on the in the homework. This one, let's see, if I had to get rid of one variable, I think I would try to get rid of, let's say I wanted to get rid of the x's. So I'm going to multiply this one by 3, this one by negative 4, and this one by 12. So that's going to give me 12x minus 6y plus 15z equals 18. Whoops, off camera there. And the next one's going to give me negative 12x minus 12y minus 32z equals negative 16. And this one's going to give me 12x minus 60y minus 36z equals 60. Now obviously I'm going to run out of room here a little bit, so I'm going to have to kind of move things around. But I can see that these two would be great to add together. And if I add those together, I get negative 18y. What is that? Minus 17z equals 2. And then if I add these two together, the x's cancel. I get negative 72y minus, wow, this is getting ugly, 68z equals 44. Boy, this is grotesque. Good news is that 18 goes into 72, so I'm going to multiply this top equation by negative 4, right? That's going to give me positive 72y and positive 68z and negative 8. And then, of course, the other equation stays the same. Negative 72y minus 68z equals 44. And I add them together, and boom, those cancel, and boom, those cancel. And I'm left with 0 equals 436. How often in your life has 0 been equal to negative 30 or equal to 36? Never true. So you need to make the right conclusion. No solution. Oops. Got to be able to spell, you know, in case you want to graduate high school. No solution. So some of these could end up being no solution. Now, I'm not going to barrage you with a bunch of no solution questions where you do a lot of elimination and end up getting no solution at the very end. A lot of times you'll find that you have one solution. Okay? So, we will talk more in class.